Dear students, on behalf of Netaji Subhash Open University, we are going to demonstrate some laboratory practicals reaction in which we can demonstrate the reactions involved in BDFT classes. Here, the demonstration divided in two parts. In first part, we will demonstrate the qualitative analysis of organic compounds, and this will help to identify the organic compounds which will be delivered to your laboratory classes. Now, the common functional groups which is present in an organic compound may be classified in two classes. One is nitrogen containing functional group and the another is non-nitrogenous functional group. In place of nitrogen containing functional group, the group remains amino group, nitro group, amide group. For non-nitrogenous functional groups, the main groups present may be alcoholic group, phenolic group, aldehyde group, ketone, carboxylic acid, and halide. Halides may be chlorine, bromine, or iodine. Now, the steps for qualitative analysis of an unknown samples. There are three main steps. In first steps, the functional groups are detected through three types of tests, which I will demonstrate in this session. After that, the functional group may be determined, the derivative of the functionalization may be prepared, and after that, the melting point of the crystallized derivative tell us the organic compounds. Now, due to short time, we will demonstrate the first part, that is functional group detection. In functional group detection, there are so many functional groups, so we have to think logically. In this session, we will only test the functional group detection. For detecting the functional group, three main steps should be followed. First of all, detection of special elements. Now, we will test the Lassaigne test, which will help us to detect the special element present in our organic compound. The special element present in our compound may be nitrogen, sulfur, chlorine, bromine, and iodine. That may be determined by our following test. For Lassaigne test, we require sample, sodium metal, motor pressure, fusion tube, filtering unit, distilled water, test tube holder, and Bunsen burner. Now we will do the test. At first, we have to take one sodium metal. Sodium metal must be freed from the paraffin oil so that it will be dried, and take the sodium metal into the fusion tube. Hold it with the tongs and melt it over the Bunsen burner. When the sodium metal melts, pour the sample. It may be solid or liquid. Then pour another sodium metal in it for better fusion. Again, make the metal oil free. Now heat the sample with the metal strongly. made the sample red hot. After proper heating, the compound is dipped into a mortar pressure filled with distilled water. Grind it with the pestle to make it a uniform solution. Now, filter the solution. Now filter the mixture. The filter was divided into 5 parts. For the first part, we will test for nitrogen, that is push and blow test. For push and blow test, we need sodium extract, ferric chloride solution, freshly prepared ferrous sulfate solution, concentrated HCl, and boiling bath. At first, we have to add freshly prepared ferrous sulfate solution to the sodium extract. Shake it and boil the mixture. After boiling, cool the mixture under tap. Then add 2 drops ferric chloride solution. After that, acidify the reaction mixture with 2 drops concentrated HCl. If Prussian blue color or light green color appears or any precipitate of green color appears, then it indicates that our organic sample contains nitrogen containing functional group. For test of sulfur, we need another part of the sodium extract, sodium nitroprusside solution, sodium hydroxide solution. And the test is as follows. At first, take the sodium extract, add 1 or 2 drops of sodium hydroxide solution, Then add 1 drop of sodium nitroprusside to it. A violet coloration indicates the presence of sulfur containing functional group in our organic compound. For the test of chlorine, we need another part of the sodium extract, silver nitrate solution, ammonium hydroxide, concentrate HNO3. Now, sodium extract, add few drops of concentrate HNO3. Then boil the mixture over Bunsen burner. And cool it over tap. After cooling the solution, add 1 drop of silver nitrate solution to it. White precipitate appears. The white precipitate, which dissolved in ammonium hydroxide, and reappears on addition of concentrated HNO3, confirms the presence of chlorine atom. So, our organic compounds contain the chlorine as a functional group. For test of bromine, we need another part of sodium extract, CCl4 chloroform, chlorine water, and concentrate H2SO4. Now, for this reaction, take 2 ml of sodium extract and add 1 drop of H2SO4 to it. Then add CCl4 or chloroform to the mixture. Add appropriate amount so that it can be distinguished by 2 layers. Now add few drops of chlorine water to it and shake well. The organic layer turns brown or yellowish brown, which indicates the presence of bromine functionalization in our sample. Similarly, for test of iodine, we need sodium bicarbonate extract, sodium extract, chloroform or CCl4, chlorine water, and H2SO4. For this reaction, we treat the sodium extract with 1 drop of H2SO4. and shake well. After that, add 2 ml of chloroform or CCl4 in it. Then add few drop of chlorine water into the mixture and shake the mixture well. The organic layer turns violet, indicates the presence of iodine functionalization in our organic compound. So for Lassaigne test, we summarize the reaction. If we got nitrogen, then we got Prussian blue coloration at the end of the reaction. If we got sulfur, we got violet coloration at the end of the reaction. If we got chlorine functionalization, then we got white precipitate in acidic medium. In presence of bromine, we got brown or yellowish brown coloration in the organic layer, and in case of iodine, we got the violet coloration in the organic layer.